This video, which is using arc lengths and sector perimeters to find the radius or sector angle, is going to rely on rearranging formula. Imagine now we're given the arc length, which is L centimeters, and we're trying to find the radius. So that's the arc length that we know, and the arc length is given to us by what fraction of the circumference is it? It's A divided by 360 times by, and that is the circumference. So if the arc length is a fraction of the circumference, if we multiply both sides by 360, we end up with 360L on the left hand side, and on the right hand side we've just got A times 2 pi r, and we can write that as 2 pi AR. Now, in order to leave r on its own, because that's what we're trying to find the radius, we need to divide both sides by 2 pi a, and that will leave the radius all on its own. So let's see that with a numerical example. In this example, we've got an arc length of 15 centimeters. So the fraction of the circle that the sector represents is 80/360 times by 2 pi r. That will give us the arc length, which is 15. And note now, in that equation you can see on the screen, the only thing we don't know is r, and that's what we're trying to find. So our first step is to times both sides by 360, and that gives us 5,400. We now need to leave r on its own. Now r is being multiplied by 80 times 2 pi, therefore we divide by 80 times 2 pi. And when we're doing that, put 80 times 2 pi in a bracket in your denominator for when you use your calculator. That's really important. Tap that in your calculator with the brackets and then round off, in this case, to 3 significant figures. Here's example 2. The arc length now is 42 centimeters, and that arc length is 210/360. That's the fraction of the circumference. So 210/360 of the circumference equals the arc length, which is 42. As before, let's get rid of that denominator. So we'll multiply both sides by 360. And that will leave us on the right hand side with 15,120. We want to leave r on its own. R is being multiplied by 210 times 2 pi, and therefore we want to divide both sides by 210 times 2 pi. As before, we put brackets around the denominator. That's really important for when we're using our calculator. We tap that in our calculator with the brackets, and then we round off to 3 significant figures. In example 3, there is an important difference from the 2 previous examples. This time we're not given the arc length, we're given the perimeter. Let's see what difference that will make to our calculation. So the fraction of the circle that sector represents is 135/360. And so that arc length is 135/360 times 2 pi r, 2 pi r being the circumference of the circle. And we simplify that to that expression. But that's the arc length, but we're given the perimeter. So for the perimeter, we need to add the 2 radii, r centimeters plus r centimeters. So our expression for the perimeter is the arc length and then plus 2r. We've added the 2 radii. Now in that expression, we should be able to see that r appears in both terms. It's a common factor. And so we can take r out as a common factor outside the brackets. And then what should go inside the brackets? Well, in our expression, what is r being multiplied by? First of all, it's being multiplied by 270 pi over 360. So that would be the first thing in our brackets. What else is R being multiplied? R is being multiplied by plus 2. So that would also appear in our brackets. So now that's a factorised expression for the perimeter, and we're told that that perimeter equals 30 centimetres. So that gives the equation there on the right hand side. Now just be a little bit careful. We're going to divide both sides by the value of this bracket. So in order to calculate this bracket, it's 270 pi divided by 360. Calculate that and then add 2 to the answer. And when you've got that final answer for the bracket, it's 30 divided by that final answer. And if you've done that accurately, you should find that you get 6.8867, which rounded off to 3 significant figures is 6.89. In this next set of examples, we're now going to be finding the sector angle when we're given the arc length or perimeter and the radius. So in this example, we're going to be given, say, the arc length. We'll just call it L for now. And because the fraction of the sector is A out of 360, that's the fraction of the circumference that equals the arc length. Now we're trying to find A, so we're going to multiply both sides by 360. And in order to leave A on its own, we need to get rid of that times by 2 pi r, and therefore we divide both sides by 2 pi r. And that gives us our expression for A, 360L divided by 2 pi r. It's not a good idea to try and remember that. Let's just be clear on what the method is so we can apply the method to any example that is given to us. So in example 1, we're given the arc length of 4.6 centimetres. What fraction of the circle is that? That's A out of 360. So A out of 360, that's a fraction of the circumference equals the arc length of 4.6. We multiply both sides by 360. So we're left with A times 2 pi times 7. And in order to leave A on its own, we need to divide both sides by 2 pi times 7. And then it's important that when we're calculating A, we put brackets on the denominator when we're tapping that into our calculator. And you should get 37.7 degrees to 3 significant figures. In this example, find the sector angle if the arc length is 49 centimetres. So that's the fraction of the circle, that's the sector, the yellow sector, A out of 360 times 2 pi times 9, 9 being the radius. And that equals 49. We multiply both sides by 360. And when we do, on the left-hand side, we're left with A times 2 pi times 9. In order to leave A on its own, we need to divide both sides by 2 pi times 9. And when we do, put brackets in the denominator for when you're tapping that into your calculator. And if you calculate that correctly, you should get 311.943, which is 312 degrees to 3 significant figures. Example 3 can seem a little bit confusing, trying to find the sector area given the arc length. Really what I want to do is, given the arc length, we want to find that sector angle A and then use that sector angle in order to find the sector area. So the fraction of the circle is A 360ths times by 2 pi r, that gives us the arc length of 25. We multiply by 360, we divide by 2 pi times 6, put brackets around that denominator when you're tapping in, and we should get 238.732 for our sector angle. The sector area, therefore, that's the formula for the sector area, where A is the sector angle, And if we use 238.732 and tap that in our calculator carefully, we should get 75 squared centimetres exactly. Might seem somewhat surprising that we get an exact value from quite a complicated calculation. In the next slide, let's see why. If we look at the two formula for the arc length and the sector area, they have similarities. First of all, we've got the same fraction involved. In the arc length, we've got a fraction of the circumference, so we've got 2 pi r. In the sector area, we've got a fraction of the area, pi r squared. If we could change 2 pi r into pi r squared, it'd be exactly the same formula. So in order to do that, the first step would be to divide by 2. So now the arc length formula would look like that. And to get from r to r squared, we'd multiply by r. And if we have a look now at the two formula, they're exactly the same. So the two steps to change the arc length into the sector area, the first step is to divide by 2, and the second step is to multiply by r. So if we apply that to our arc length given to us, which was 25, divide by 2, and then multiplied by the radius, which is 6, that gives us 75, which was the answer we obtained doing the question the previous way. And I think you'll agree that's a simpler way of doing it. And lastly, our final example, just be careful, once again, we're given the perimeter, not the arc length. So the arc length plus a radius equals that perimeter, which is 16. Now, if we take one of the radii off and then take the second radii off, we've just reduced the distance around that sector by 10 centimetres. So that must mean the arc length is 6 centimetres. So once we've got the arc length equaling 6 centimetres, there should be a method that's familiar to us. The fraction of the circle is a out of 360 times 2 pi times 5. Remember, 5 was the radius, and that equals 6 centimetres, times by 360, divide by 2 pi times 5, well, that's just 10 pi. Tap that in your calculator, make sure you put the brackets on the denominator. You should get 68.754, and we'll round that off to 68.8 to 3 significant figures.